Chapter 4-5, continuing here. We're actually doing the graphs of it. Now, what do I want you guys to get? First of all, ready to the graphing calculator out. We're going to do a couple graphs here, make sure that you guys understand some things here. I want your books open to page 263. 263. 263. Now, on page 263 in the lovely little shaped box, it talks about even and odd trigonometric functions. An even function would be what? Cosine would be an even function. What's it mean to be an even function if you're talking graphically?
Positive.
Positive to positive, very good, I like that. So the cosine in quad 1 is the same thing as the cosine value in quad 4. Which means if you're in quad 2, the cosine value, which is negative, is going to be exactly the same cosine value of that angle in quad 3, which is also going to be negative. Which means if I hold this over the x-axis, they're going to lie directly what? On top of each other. That's what an even function looks like. Now, why am I asking you about this? Because let's say I have to graph y is equal to the cosine of x, and then I have to graph y is equal to the cosine at negative x. Well, essentially what this thing is doing is it's asking you to graph the two functions that appear to be two separate functions, correct? But are they technically two different functions? No, according to page 263, they're going to be what? Exactly the same. Well, how do I prove that to you? Well, let's look at the graphs of these. So what I want you guys to do, I want you to get out a graphing calculator doc here. I want to see the graphing part. And I want you to simply graph the cosine of x. So if I graph the cosine of x and press enter, there's my graph. Now I want you to hit tab, and now we're going to graph the cosine of negative x. And hit enter. What do you notice? They're exactly the same. Well, were we expecting those to be exactly the same?
Yes.
Yes, because we know that that's an even function. Do we understand that, yes or no? Okay, well, let's talk about the sign. If I have these two graphs will be exactly the same, right? However, what about these two graphs? The y is equal to sine of x and y is equal to sine at negative x. Will those two be the same? Stop, don't do it yet. Don't do it yet, Morgan. Put down the calculator. Okay, on page 263, what type of a function is sine? The only even trig function is going to be cosine, which means they will be exactly the same. But the only odd function that we're going to have that we're talking about today is going to be sine. What's it mean to be an odd function? It means the only way that they would be the same is if you fold it over the x and then fold it over the y-axis. Meaning, if you look at your quadrants, for my sine values to be the same, I have to fold that over the y-axis for them to be the same. Okay? But by definition of an odd function means it's symmetrical according to the origin. Meaning you fold it over the x and then you fold it over the y. Okay? Well, let's look at these on the graphing calculator. If you look at these on the graphing calculator, I'm going to get a new page just so that I don't have a whole bunch there. Trig sine of x gives you that. Tab trig sine at negative x is going to give you this. Okay? What does it look like? So what you're telling me is it does look like a helix, doesn't it? It looks like a DNA helix. But what does it actually look like whenever you're talking about this graph?
X, Y, line thing will be really good.
The max, the level, max, level, min, level pattern, what does it turn into? The opposite. So I go from a level to a level, from a max down to a min, right? So now I'm going to have level, min, level, max, level. This is because this is an odd function. In other words, by definition of an odd function, if I'm going to graph y is equal to the sign at negative x, that is the same thing as graphing negative sine of x. Do we understand that? And what do we know happens whenever you put a negative in front of the trig function? It flips it over the x-axis, doesn't it? Do we understand that? It flips it over the x-axis. So every time you see a negative within the angle, when the angle is negative and you're dealing with a sine function, you can simply think of that as putting the negative in front of it, right? Many of you are dazed off and not listening to everything I'm saying. Many of you. What did I just say? Only when you're using sine. Thank you, Zach. Good job. When you are dealing with a sine function and you have a negative angle, you can simply ignore the negative angle and put the negative where? In front of the trig function. If I'm dealing with the cosine, though, do I need to acknowledge the negative when dealing with the cosine if it's a negative angle? No, because they're exactly the same graph. Do we understand that, yes or no? Okay. Now, let's go ahead and let's talk about problems 1 through 3. Look at problems 1 through 3. Which one do you want to do?
Maybe I want to do
Problems 1 through 3. Who wants to do 1? Who wants to do 2? Who wants to do 3? One it is. That's so easy to one of these. Yep. Okay. Now, if I have y is equal to 2/3 sine of x, first thing you need to do is what? Well, what's the direction say? Determine the amp, period, interval, max, min, values. And notice there's a level on there now. And then sketch the graph of following over one complete cycle. Put the graphs on the graph paper. Use the space below for your tables.
amp first.
I need my amp first. So what is my amp? My amp is going to be my A value. What's my A value? 2/3. Okay? Now what's my maximum at this point? Without looking at if I have a C shift, what would be my positive max according to my amplitude of 2/3? I'm going to repeat this. Your amp changes the height of your graph, correct? So without looking at the rest of the equation, the max would be what? 2/3. Without looking at the rest of the equation, my minimum would be negative 2/3. So positive amp is 2/3. Negative amp would be negative 2/3. Are we good with that? Now, my maximum values. My max is my positive amp plus C. Do I have a C in this equation? No, my C is 0, which means my positive amp is just going to be 2/3. To give me 2/3 as my max. My level. What is level always at? 0. 0 is level, so I'm going to add my C value to that. So my level is simply going to be 0. My minimum. My minimum is my negative amp plus my C value. What's my negative amp? Negative 2/3. If I'm adding C to that, that's going to give me 0 to give me negative 2/3 as my minimum. Do we all understand where to get your max level min from? Yes or no? Positive amp plus C, level plus C, which is 0 plus C, and then it's going to be your minimum is negative amp plus C. We good? All right. Now what do I need to find? Your period. How do you find your period? 2 pi divided by the absolute value of B. Why is it 2 pi? Because that's one complete cycle around the unit circle. Yes, we understand that. For sine and cosine, the normal period is 2 pi units. Why is the absolute value of B again? Why can't it be negative? Well, you can, because sine goes both directions, right? But what does the period represent? When you're looking at it graphically, Booker, what you just talked about is it goes in both directions. But we're talking about a distance, aren't we? And if we're talking about a distance, can distance ever be negative? No, because you're measuring the distance, which is why it's the absolute value of b. We all get that. Okay, so with that said, I'm going to have 2 pi divided by what's b? Why is b 1? It's what's in front of your x, right? So therefore, it's going to be 1 to give me 2 pi as my lovely period. Okay, now what do I want to find? Your interval. Your interval is going to be how many units you have in between each one of your points on your angles, right? Well, how do we find our interval? It's going to be your period divided by what? 4. Okay, well, let's think about this a minute. How many points am I supposed to have then? Well, if we're looking at a unit circle, what was our whole game plan? What did we want to land on always? Well, what did we want to land on? The axes, right? We wanted to land on our axes. So what's the first angle we wanted to land on? Well, where do you start? Where do you start?
0.
0. There's 1. So that's the next one. 90. What's the next one? 180. What's the next one? 270. What's our last one?
360.
360. So how many points should we have? We should have 5 points, right? We always exclude our first starting point, because our starting point tells us that's where we're going to begin, and then there's 4 points afterwards. Okay, and those 4 points need to be divided up equally, distance. Okay, now my period is 2 pi, so I'm going to take my 2 pi and divide it by 4 to give me pi over 2. In other words, when I do my lovely little xy table, I'm going to start at 0, and then what am I going to add to that?
Pi over 2.
I'm going to add pi over 2 every time. So I have all the information I need now to make my lovely little...
I like the way this works.
You're welcome. Now I'm going to take my lovely little xy table, and I'm going to plug and chug. What's my starting point at always?
0.
0. And what am I adding to it every time? Why pi over 2? Because that's your interval. So 0 plus pi over 2 is pi over 2. What's pi over 2 plus pi over 2? Pi. What's pi plus 3 plus pi over 2? 3 pi over 2 plus pi over 2 gives me 2 pi. Now, are we listening? Where do we always start at today?
0.
Where do we always end at?
2 pi.
Nope. What's our goal?
R, period.
Why are we ending at our period? Because we want to graph one complete cycle. And a complete cycle is how many revolutions it takes to go around the circle. 1 revolution, right? To get all those lovely little spots on our unit circle. Do we understand that, yes or no? So we start at 0, we end at our period, and this in between is going to give us our intervals, right? Those angles. We come up with those angles by adding our interval each time. Are we good on that, yes or no? Now, what is the pattern of sine? What is the pattern of sine? We know it's a nice little squiggly curve, but what is the pattern of it? Write it down on Friday. Level, max, level, min, level. We know that's what that is. So I have a level, a max, a level, a min, a level. That's what the pattern is of sine. Now my question to you is if I'm graphing 2/3 sine of x, is there any reason for me to think that this pattern will not work? Is there a negative out in front for my amp? Nope, so it's not reflected. Is my sine x angle inside there negative? No, so I don't have to worry about that. So is there any reason this would not hold true? So how do I make sure without doing very little work that I'm correct? Well, I've simply plug and check the first round. 2/3 times the sine of 0. Well, what is the sine of 0? Well, where are we coming from here, folks? Which of those coordinates do I want? Do I want the x coordinates or do I want the y coordinates at I want the y coordinates. So I'm looking at all of these. Why am I looking at those? Because I'm graphing 2/3 sine of x. Do we all understand that, yes or no? So, at the sine of 0, what is the sine of 0?
0.
The sign of 0 is going to be 0. 0 times 2/3 is?
Zero.
Was that my level? Yes. Go to the next one and plug it in. 2/3 times the sign of pi over 2. What is the sign of pi over 2? What is the sign of pi over 2?
1.
1. So that turns into 1. So what is 2/3 times 1? Was that my max? Is there any reason for me to believe it's not going to continue the pattern that I know it to be? Do I have to fill out the rest of this chart? No, all I have to do is do my level 0, my mid negative 2/3, and my level 0. And now I know that I'm right. So am I going to force you guys to fill out the chart every time? You only have to do the sheet, which is the middle column, whenever you think you're going to be wrong. So I did the first two, I can see my pattern was correct, and I didn't have to continue on. Do we all understand that? Okay? So now let's go ahead and graph it. So how would I graph this? Zero is right here. Where's positive 2/3? Up here. Where's negative 2/3? Down here. Do I care how many units you guys have on there on yours?
Doesn't matter what it's started.
Doesn't matter to me. Okay? I am simply going to add my angles. Pi over 2, pi, 3 pi over 2, 2 pi. Keep them equal distance from each other. Maybe some of you want to use 5 units between each one of them. Maybe some of you want to use 3 units between each one of them. 3 squares. I don't care. Just be consistent. Do we all understand that, yes or no? Okay? So now, at 0, what's my angle? At 0 angles, what is my sign? 0. At pi over 2, what was my sign? 2/3. At pi? 0. At 3 pi over 2? And at 2 pi? Now, you see those dots? Do not give me pointed little peaks and depth valleys that have little points on them too. Okay? I want curves. I want to see a nice mound. Do we see that, yes or no? There's your sine curve. Now, sometimes I may ask you to graph, give me 2 complete cycles. Well, how would you do 2 complete cycles? Do I need to do another chart for 2 complete cycles? No, all I have to do is continue this out, and then I'm going to have 2 pi. Remember, this is going to be 3 pi over 2. That's going to be 4 pi over 2, so this is going to be 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. Well, 8 pi over 2 turns out to be 4 pi. This turns out to be 3 pi. Do we see that, yes or no?
Should we write this down?
I'm just going to quickly show you. Don't put it on your homework. I'm just going to show you. Again, we have our level, we have our max, our level, our min, our max. And we just completely go with our curve. Do you see now I have 2 complete cycles there? Did I have to do another order pair or another table there? I didn't. Do we understand that, yes or no? I only want the red if I wanted 2 complete cycles. You attach the blue. Do you all get that, yes or no? Okay, turn it over. Would you like me to do another one with you, or you want to be on your own? Can you come look at this real quick?
Can we do a cosine one?
I don't want to
4.
That is 2.2.
Can we do 6?
Okay. Look at the back. Who in here wants me to do number 4?
Oh, maybe 6.
Who in here wants me to do number 5? Who in here wants me to do number 6? Number 6 it is. Number 6, y is equal to the cosine pi x minus 2. Okay. Step 1, what should I find here? I need my amp. My amp is going to be equal to 1, right? More importantly, watch this, plus or minus 1. Why am I putting that plus or minus 1 concept there? Because I know my positive amp is 1 unit, and my negative amp would be negative 1 unit. That all is going to be contingent upon what? My max, level, and min change based upon what 2 variables? There's 2 things that change your max, level, and min. Your C, which is your vertical shift, and your amp, which is your A. So, if I want my level, little max, my max is going to be my positive amp, plus c. My positive amp is what here? Positive 1. What's my c? Minus 2 to give me negative 1 as my max. My level. What's my level now? 0 plus c. So I'm going to have 0 minus 2 to give me negative 2 as my level. And my minimum is going to be my negative amp plus c, which is going to be negative amp is negative 1 minus 2 gives me negative 3 as my minimum. Okay, before I go on, can anybody tell me what the pattern of cosine is? Sorry? What's the pattern of cosine?
Yeah, level, min, level, max, level.
It's going to be your max, level, min, level, max. Do we understand that? That's what the general pattern of cosine looks like. Agree? Now my question to you is this what that's going to look like? Am I flipping it by any means? In other words, is my amp negative? No, my amp is not negative, so I'm not flipping it over the x-axis. Is my angle negative? My angle is pi x. Pi is a number, right? So am I flipping it? No. So I know my max, level, min, level, max is going to hold true here. Do we all understand that? Next, what do I need to find? Your period. How do you find your period?
Pi over 2 divided by B.
Very good. 2 pi divided by what? B.
Pi.
Pi. So what's pi divided by pi? That is gone, and I'm going to be left with 2 as my period. How many people are 100% bothered by that? Okay, well, let's talk about that a minute. Anytime you have a pi in there, pi is just 3.14. Remember, if you have 2 pi, that's 6.28, right? In this case, you can actually physically see it's going to be 2. Okay, so on your actual x-axis, you're going to see numbers that you're used to graphing now. You're no longer going to see those ugly little angles that have pi's in them. Does that make sense? So this actually becomes an easier problem for you. What's the next thing I need to find?
Interval.
Your interval. So how do I find my interval?
4 divided by, period.
Period divided by 4. So what was my period? 2. 2 over 4 reduces down to? 1/2. Okay, well, how in the world is this helpful? Because where do I always start at?
0.
I start at 0. Why am I starting at 0 today? Because what type of graphs am I dealing with? I'm only dealing with a vertical shift, meaning the c value. I don't have a horizontal shift in there today, do I? Okay. So what I'm going to have here is I'm going to have x, y, and I'm going to have the cosine of pi x minus, what was it, 2. I start at 0, and then what am I going to add to it? 1/2. What's 1/2 plus 1/2? 1/2 plus 1. 1.5, which is 3 over 2, and 1/2 plus 3 over 2 is going to be 2. Doesn't that look very similar to what we had before? Except for what is missing there? The pi sign is missing, but those are exactly the same things that we had before. Okay? Now, what did we say this thing was going to look like? Max, level, min, level, max. That's what we said it was going to look like. So how do I confirm this? I plug in the first ones here. Cosine of pi times 0 minus 2. That means I'm doing the cosine at 0. What's the cosine at 0? 1. Very good. So I'm going to have 1 minus 2, which gives me negative 1. Is that my max? Yes. Go to the next one. Cosine of pi times 1/2 minus 2. That gives me pi over 2. What's the cosine of pi over 2? Up top, 90 degrees. Cosine will be 0. So that's going to give you 0 minus 2 to give you negative 2. Is that your level? Is that your level?
Yeah.
Yes. So what should be the next value?
Negative 3.
Negative 3. What should be the next value? And the last one?
-1.
Okay. So now I have all those points, right? Now I need to graph this. Now this is what I was talking about. Okay? Notice I have my nice little line there, my vertical line. Where do I put my horizontal line at? In the middle, towards the top, towards the bottom,
Where the bottom
towards the top. Why towards the top?
Oh.
Because what are my max level min values? -1, -2, and -3. So what I need to see are going to be -1, -2, -3. Do we see that? Yes or no? That's what I need to see on my graph paper. Do we all understand that? So on my x-axis, I need to start labeling those points. So that's going to be 1/2. That's going to be 1. That's going to be 3/2. And this is going to be 2. Do we see that? Yes or no? Now, what will help you guys out is if you put a nice invisible line here at level. Why am I telling you put that nice invisible line there at level? Because the whole thing has been shifted down 2 units, has it not? And it's hard for you guys to draw a nice curve without seeing that x-axis to help you make everything level. So if you have that nice invisible line there, you'll be able to say, hey, that's definitely not straight, is it?
No.
Is it now?
Down. Down. Nope. Up. Up.
It's not going to do it.
I think it's because I'm in that view.
Maybe your top one is going that way.
I think it's my top line too. So what have we learned? Yoder cannot draw a nice straight line. Okay. Now, this is going to help because we're going to go ahead and say at 0, what's my first value? We have a max at -1. At a half, we're going to have a level. At a 1, we're going to have a minimum, level, and then a max. And then you can see your curve. You see that, yes or no? You see why I say maybe drawing that nice invisible line? You guys are going to be able to do a lot better because you have your nice little graphic points there, graph paper. That'll help you. Any questions over this today? Do you feel like you understand what you're doing? Yes? Okay, tonight all you have to do is finish those 4 problems. Check Edmodo, because I'm going to have probably another video, probably about a 5-minute video, 10-minute video is going to add with this. It's going to add the horizontal shifts. That's it. So what's going to change tomorrow is going to be your starting and ending points. Any questions over what I just said? Okay?